Hi there, my name is Mark Brown. This is a Super Home 59 video all about solar power, solar thermal and photovoltaics. But before we do anything, come for a walk outside. Most of the panels are photovoltaic for electricity. We have 2.96 kilowatt peak capacity there, and that's most of the panels. But on the right, there we have solar thermal tubes for the hot water. Okay, where to start? We have solar panels, what we do. Where do we go next? Well, let's go upstairs, look at the solar thermal system that's in the attic and in the airing cupboard. Let's have a look at those controls. Now at this end of the attic it's quite cramped. I'm now behind. This is the solar thermal pump system. These are the pipes going in and out here. These pipes here are going down to the airing cupboard below into the solar tank. The panels themselves are in this direction on this roof, and they come via piping all the way down to here where my hand is, just above. Here's an expansion tank, and this plastic tub is an overflow in case anything goes wrong with the system. So what's the point of this box of tricks? Well, let me zoom in and show you. So here we are in the airing cupboard, and this is the controller box for the solar thermal system. And if I zoom in a little bit, you can just about see what's going on here. Here's some sunshine, here's a panel, and you can actually see it moving, the little pump at the bottom there. And this represents, this diagram here represents the cylinder in the airing cupboard. The temperature 55 here is in degrees Celsius. That's the temperature at the top of the tank. You know it's top of the tank because of this little T3 symbol here. If I press that up button, you get T1, and that's actually the temperature on the roof, which is 53 at the moment. If I get down to 55 and then down again, I get 39. 39's at the bottom of the cylinder, and again in degrees Celsius. So this shows us the sun's out, the pump's working in the attic, and the glycol solution is circulating around and it's heating up the hot water. Okay, as simple as that. The central heating system itself, the biomass boiler, only heats the temperature of the domestic hot water cylinder up to 57 or 58 degrees C. So the solar system is set up to heat it to a higher temperature. And the biomass system is actually not working normally during daylight hours. So the solar system actually has priority in heating up the hot water cylinder. You can heat it to a higher temperature and it can heat it during the day, whereas the biomass boiler gives preference to the sun, which is how you want it to work. Imagine if you have it set up the wrong way, then you had the solar system setting up to only heat it to 55 and the biomass boiler had it heated up to 63, then of course the sun wouldn't be doing anything. The pumps would be switched off all the time. It would serve no purpose at all. So do think very closely about how you program this, and if you're unsure, do make sure that your installer sets it up for you correctly. In our opinion, installers just plug it in and leave you, okay? But do think, and if you're unsure, please drop us an email. We'll help you through the problem. It's relatively easy to do. So that's the solar thermal system. Let's go and have a look at the electrical system. We need to go now to the garage. And here we are back in the garage. Now for the photovoltaic system, things are a little more complicated. Up in the attic there's an inverter. The photovoltaic panels themselves generate direct current at about, I don't know, 517 volts or something. Of course your mains power to your house is 240 volts and it's alternating current. So what happens is the inverter is what we call grid reference. It's connected to the grid, and it's connected to the grid via this black armoured cable here that runs down from the attic, down a drain pipe, and in through a hole in the garage behind you, and over above my head here and down here into the consumer unit, the fuse board above. So it knows what mains voltage is, and it inverts direct current into alternating current to make it match almost exactly voltage and frequency of the mains. So at that point your house can use it thinking it's just normal mains voltage. Now why would it use your photovoltaic power and not import from the grid? Well, the voltage from the inverter is slightly higher, so it has preference and is therefore consumed locally. Now this is grid connected, as I'm implying, so we get paid by the government incentive, the feed-in tariff, for every unit we produce in electrical energy. And how do we know that? Because there's a little meter here, technically called an Ofgem meter. It's not really an export meter, it's just a generation meter. It doesn't tell me how much I've imported or exported, that's a different matter. This is a digital meter. We used to have an analog one that used to go backwards when the sun shined. The power company didn't like that and they replaced it, so we now have a digital one. This little red light here, by the way, if you can just about see it, indicates we are exporting energy at the moment, so aren't we doing well? So power comes in here, goes through the meter, and then goes up here to the consumer unit here, where it's therefore consumed by the rest of the house. Okay, so up here, solar energy meets grid energy. Right, so how do we know how well we're doing, whether we're importing or exporting? Obviously, on a dark night in winter, we're going to be importing. But on a day like this, how do we know? It's lovely and sunny outside. I can guess we're going to be exporting energy. But we do have a workaround for this. There's a couple of attachments here. One is here. So what you see here, it says PV and an arrow pointing down, basically back to the photovoltaic panels. And what this is a little magnet strip with a wire coming out of it, and that hooks around the wire coming from photovoltaics. And we follow that up to a wire here, and if you look closely, that wire goes up to a box of tricks. And this is the box of tricks here. It's called an EcoEye. It's a real-time electricity monitor. You may have seen or heard of an OWL monitor. This is a similar principle, but what it does, it has multiple inputs. So there's another wire here going up to here. That goes up here to the main supply, and that tells us how much power the house is using. And then there's a black wire here, which is a voltage measuring device, effectively bolted onto the grey cable, that tells the EcoEye, gives it a reference point, gives it an idea as whether the power is going in or out of the house. So that's a wireless system, and that's connected, pan down again, this system here, wirelessly is connected to a meter that's inside the house, and we'll have a look at that next. So this is the receiving station for the EcoEye. It's a large LCD display covered in buttons. It actually is not the easiest little dinky toy to play with, but it's a basic energy monitor. Now the readout at the moment, it's 0.293 at the moment. That's the actual consumption of the house. It's ignoring the PV, basically, so that's what we're using now. And as you can see, it's going up and down. You can probably track which appliances are clicking on and off. The fridge is running at the moment, which is probably why that's slightly higher than normal. I won't go through the controls with you, it's not really very important. But I will give you one little bit of advice. These lights here, the traffic lights that are flashing, one's red, one's amber, one green. The green means you're exporting energy, the red means you're importing, and the amber's kind of, well, indecisive, somewhere in between. So are we importing or exporting? It's a sunny day, I'm going to pretty much guess that we are. After all, we're only using 226 watts at the moment. We have a 2.9 kilowatt system on a sunny day. I reckon we'll be generating in the order of several kilowatts, and that will vastly exceed the demand of the house, therefore we'll be exporting. So here's the EcoEye, and there's the Fronius inverter readout. That's also a wireless device handled via the attic inverter, so I can in fact completely remove this. It's reading at the moment 2024 watts, so 2024 watts is being generated from the roof, and up here we have 274.274 actually, remember the decimal place. So we're generating 10 times more the energy from the roof than we're currently consuming inside the house. This has been a Superhome 59 video about solar power and solar energy, solar thermal and photovoltaics. We've shown you the metering, we've shown you the wiring, the controlling mechanisms, and tried to explain that it's actually quite easy. It's hands-off, there's no maintenance, it's quite easy for you to use. If you want to visit the house and talk more about these sort of devices for your home, then visit us at www.superhomes.org.uk/59 and you can click on the link there to contact us to arrange a visit, and we look forward to meeting you. In the meantime, don't forget that you too can conquer your house.